I see a number of you are still trying to join in. Hopefully they'll increase number by the end of the meeting. But I just wanted to highlight one or two things before the meeting starts, so that we are all on the same page. So what we are going to do for business statistics is we're going to do 2 free lectures for you guys, where we are just introducing the concepts of business statistics so that you are aligned and in what the module is all about. So we are from Varsity Unlimited Tutors, a tutoring organization that assists students with tutorials in order to understand the various difficult subjects that they might face at university level. Your lecturer today is going to be Kudasvanda. He's a statistician by profession, and I'm sure that you have a wonderful time. He will teach you the ABCs of statistics, what you need to know, and etc., so that when the time for the assignment comes and when the time for the exam comes, you'll be well prepared for it. Then after the first 2 lectures, for those of you that want to continue doing lectures with us, the cost is 700 for the entire semester for business statistics. This includes lessons, this includes videos, this includes exam preparation, and also include guidelines in terms of the assignments that you're going to receive from your lecturer. So it's all inclusive of all of those things. So we are just going to be making sure that when assignment time comes, you are well prepared for your assignment. You are going to get your 30 out of 10 assignment. And then when the time comes, you are also well prepared for the exam, so that you get your distinction at the end of the day. I'm not gonna say much more. I'm gonna leave you guys to speak with him. If there are any other questions, you can post them in the group. I'll also send my full details in the group for the banking details, etc. if you need to make the payments within the next 2 weeks. Thank you guys for coming in. I hope you have a pleasant time. Koda?
Okay. Thanks, James. A warm welcome to you guys. And I just want to take this wonderful opportunity for you guys coming through. And so my name is Kudas Banda, just like James highlighted. So I'll be the one who will be taking you for business statistics. So generally, this is an overview, right, of how we are going to be conducting our lectures. So basically, this should give you an idea, right? This should give you an idea how we'll be doing our lectures, and how I'll be trying by all means to explain the key concepts that your lecturer would have put in the study guide, right? So generally, my lectures, I try to make them as much interactive as possible. When I say interactive, I mean I try by all means to make sure that you guys participate, right? You also participate. Of course, I will be the one who will be delivering the content, but you guys also have got a part to play where maybe I've explained a certain concept and you didn't really grasp it, or you didn't really get it. So you don't have to wait for the lecture to finish, right, for you to raise up a certain question. So normally what I do is I allow people to ask questions at that time where that question arises. Maybe I'm explaining a certain concept and then you don't really understand, so you feel free either to chat in the chat box, or you unmute yourself, right? Most of the time I prefer that you guys unmute, and then so that we can clarify, because if we wait for the lecture to end and you guys sometimes you might forget and so forth, so it's better to explain a certain concept while it is still fresh, right? So today what I'm going to do is we'll start like much into lecture doing what is within your study guide next week. So today what I managed to prepare for you guys is just an assignment, right? So that at least you can have an idea, you can appreciate what statistics is. So let me make this disclaimer before we go any further. Statistics is not a theoretical course. So statistics is a mathematical course. So generally we are just going to be making calculations, right? So some of the calculations I'm just going to show you today, right, just for you guys to have an idea, so you see and appreciate statistics in general, so that at least you can see how we go about, you know, writing formulas, you know, and explaining the key concept behind, you know, the statistics, right, in general. So let me just, okay, James, are you able to, because I can't share, I don't know if James is hearing. James, can you kindly give me the privilege of sharing? Okay, let's see. All right, thank you so much. Okay, so right. So this is what? This is a typical assignment, right? This is a typical assignment. So you can see from this assignment, so 30 marks, right? So this is how your lecturer will ask some of the the statistical concept and statistical things, right? in the assignment. So I just took an example of an assignment, so that is just, you can have an idea, you can appreciate, right? You can appreciate statistics in general, right? So the following data give the hourly wage rate in rands for a sample of 20 workers. All right, let's see. Oh, the signal is bad. Okay, guys, someone is saying that the signal is bad. Is it my signal, or could it be a signal? Can someone just verify if I am breaking? Guys, because I'm just assuming that everything is fine, unless maybe someone, the signal is good. All right, thank you so much. So it means that Mary, it's your connection that side, right? It's your connection. Okay. All right. So we are saying that there are 20 workers. So those are the hourly wage rates that they've been given, right? All 20 of them. So now the questions now are revolving around the what? The data that we have been given. All right. Guys, just make sure maybe to mute. If you're not muted, just kindly mute, so that, all right, there won't be any feedback, right? Okay, so now the first question is, using raw data, determine the range, right? So now let's try to tackle up what do you call it? Let's try to tackle up these questions. All right, let me try to share. All right. Okay. All right. Okay, so just confirm if you can see the Word document. So let me start by explaining some concepts, right? Let me start by explaining some key concepts before we go any deeper. So I'm not so sure if this is your first what? Your first if maybe it's first time coming to realize something called business statistics, right? Maybe it's a first time meeting that term. So let me start by explaining what business statistics is in general, and then I'll give a brief background of what the assignment was trying to the concept behind, right, that assignment, right, before I answer the first question. So what you need to understand is business statistics, right? It's all about collecting and analyzing data, right, in order to identify patterns and trends, right? So most of you guys at your workplace, right, maybe some of you are in management, right? So as long as you see numbers at your workplace, chances that it is statistics is very high. Chances of it being statistics, it is very, very, very high. Because some of you guys who are in management, for you to make business decisions, right, you need supporting data, right? If you are saying someone just comes and says we are making a loss, so therefore we need to make some changes, where is the proof that we are making some losses, right? So that proof now comes in as statistics. So statistics all about collecting the data. So when a person says we are operating at a loss, it means that they've collected the data, right, and they've analyzed the data. Therefore now they are saying, because of the proof of this data, we have been operating at a loss. So let's try to put some strategies for us to implement as a company so that we can have an increase in what? In profit. So that's what basically statistics is all about: collecting, analyzing data to identify the pattern, right, and the trend, right? So it allows managers to analyze past performance, right, and predict future business environments so that they are able to lead the organization effectively, right? So in order for the managers to make decisions, statistics help them to make what is called data-driven decision making, right? In order for them to make certain decisions, it's because of the data that they would have obtained from statistical analysis, right? So now coming to the assignment, right? This assignment is mainly centering on Unit 3. So what your lecturer normally does is when they are giving you an assignment, normally they just give you maybe one assignment centering on a certain unit or at a certain sub topic within a certain unit, right? So this assignment is centering on Unit 3, that is talking about what is called management statistics. So when you go under that unit, you come to find out that it is divided into certain subsections, and one of the section is what is called measures of central tendency. Then there is another section again called measures of dispersion, right? So all those subcategories are type of statistics. So now what you need to understand, the statistics is divided into two. We are going to go much deeper into this when we start the lectures next week. But just for foundation's sake, statistics is divided into two. There's what we call descriptive statistics and what we call inferential statistics. So Unit 3, when we're talking about measures of central tendency and measures of dispersion, we're talking about statistics that describe, right? They are just describing the set of data. That's why they are called descriptive statistics, right? So measures of central tendency, what they do is they describe. Can you see? That's why the word describe is there, because they are categorized into what is called descriptive statistics. So they describe the set of data, but they describe the set of data using what is called a central position within a set of data. So they use one position to describe the set of data, right? What is happening with that set of data? So there are three things that are used, three measures of central tendency. The first is mean, which is known as the average. The second is median. The third is what we call the mode. right? So don't worry, we're going to explain much of these things, right, next week. So yeah, I just want to give you an idea of how, you know, we'll be doing our lecture. So the other thing that I need to explain is data itself, the data, right? Because remember, we're saying statistics is the process of collecting and analyzing data. That data is further divided into two. So one category of that data is what is called ungrouped data, which is also called what? Raw data. Let me just highlight this word there, right? Raw data, right? So ungrouped data is the data you first gather from an experiment or study. That is the part of statistics. We are saying statistics is the collecting of data. So when you go and collect the data, that data, when you gather it, is called ungrouped data. It is raw. It is not processed, right? So it is not sorted in categories. It is not classified. It is not grouped. So ungrouped is a set of data which is basically a list of number. So let's give an example. You get into a lecture room full of people, and then you say, I want to see the shoe size of every person in this room. So when you are writing that data down, asking the person, what shoe size do you wear, right? Tell you 6. What shoe size do you wear? They tell you 8. What shoe size do you wear? They say 4, right? So when you are taking that data that you are writing down is what is called ungrouped data. It is still raw. You haven't categorized it as yet, right? You have not yet managed to put it into bundles or classes or so forth, right? Then the other type of data that we have is what is called grouped data. Now, grouped data is data that has been bundled together in categories, right? So let's go back to the example of what? The example of the people within the classroom, lecture room. So what happens now is you get into a classroom, then you say, I want all people that have got a shoe size of 7 to stand up and stand in that corner. I want people who've got a shoe size of 7 to stand up and stand in the other corner. And I want the other guys that maybe shoe size 8 to stand in that corner. What you are doing is you are now grouping people together that under a certain what? Category. So each and every person is going to fall in a certain category for them to be grouped. So now when you have grouped people under the same characteristic, under the same category, under the same class interval, under the same classification, then that data is no longer ungrouped. That data is considered as grouped data. The reason why I'm explaining this, you come to find out when you start doing the lectures, right, next week, you come to find out that the formulas for calculating measures of central tendencies for ungrouped data are different from the formula that are used, right, to calculate measures of central tendency for group data. So if a question is asking you to find mean, right, from data that you've been given, you need, before you can put a formula, you need to determine first, is it grouped data or ungrouped data? Because you can't use a formula for calculating mean for ungrouped data when the data you have been given is grouped, right? So you need to know whether the data you have been given by a lecturer is grouped or ungrouped in order for you to know the exact formula that you're going to use. So I think this is I've managed to lay a good background so that at least you can understand where what we are saying. Okay, so this is the data that we have been given, but I've managed to rearrange it from the lowest to the highest value, right? So let me reshare again so that at least you can have an idea. So these are all the values. So the lowest value is this one, 535, and the maximum value, it has to be 1590, which is this one. So I had to rearrange, right? I had to rearrange the data, right, from the smallest to the maximum value. So now coming to the first question is calculate the range. So when you go under the unit for management statistics, right, you come to find out that the under measures of dispersion, there's something called a range. So a range is used to describe how the data is spread, right? So range now is, you are saying how to calculate range, you are saying highest value minus lowest value. So if you go check in your study guide, if maybe there's someone who's got the study guide close by, right? We will start showing certain things from study guide from next week, right? Like I said, today it's just an overview, right? But if there's someone who has a study guide open right now, if you go under measures of central attendance, you come to see that there is range, and the formula for calculating range is the highest value minus the lowest value. So you can see from the data that the lowest value is 535 and the maximum value is 1590. So when you subtract the two, then you get it 1055. Right. Okay, so now let's proceed to the next question, right? It says, what percentage of these workers get paid less than less than 10 per what? Per hour, right? 10 per hour, right? 10 rand per hour. So what you need to do is, we've got 20 workers, right? We have 20 workers here. And these 20 workers, they are ranging from 5 rand to 15 rand. But out of 20 workers, we want to see how many workers are paid less than 10 rand per hour, right? So when you come and see this data, you come to find out that, let's see how many people have got values that are less than 10 rand, right? So there's this one, this one, and this one, and this one, and this one, and this one, right? If we up until this one, so this one is slightly above 10, because 10 is the limit that we must not exceed, because we want people that are paid less than 10. So this one is slightly above 10, which is 10.8, so we'll not include it. So let's count how many people have got hourly wages that are less than 10. So this is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 people. So 8 people out of a group of 20 get an hourly wage of less than 10, right? So they want a percentage. So what you do is you come up with this formula. So this one, your lecturer, what they were doing is, it's not a formula that is within statistics. They were just trying to understand if you remember arithmetic. So these are just basic arithmetic. It's not statistic stuff. It's just basic math stuff. They just want to see if you can be able to formulate just some certain concept from maths, right? So you come up with a formula: percentage of the workers that are paid less than 10 is equals to the number of workers paid less than 10 rand, which we have counted to be 8, over a total number of workers that are 20. But now remember, we want to find this as a percentage. So we have to multiply by 100%. So the number of workers paid less than 10 is 8, and the number of workers themselves, their total number of workers, they are 20. So it's 8 over 20 by 100. It will give you a 40%. So 40% of the total people, they get a what? They get an hourly wage of less than 10. So you see, first question, we got it. Second question, we got it, right? So let's continue. Let's see on the third question. So the third question is group the data into frequency distribution. So now one thing that I want you to see is The first question says using this raw data. So this data that you have been given is ungrouped, right? It is raw because it's not grouped in any way. But now they are saying, we have given you data that is not grouped. Now we want you to group the data into a frequency distribution with the lowest class limit of 5 Rand and a class width of 2. So the keywords that I want you to pay particular attention to is the lowest class lower limit. Right? The lowest class lower limit and the class width. Right? So let me first define what these class limits are and what class width is. And then we will be able to tackle this question. Because remember, this is just an assignment, right? We haven't covered as yet much of this concept as yet, because we haven't gone into the slides. So let me just give let me just define certain terms first, and then I'll show you how you group the data. So let's start by defining what is called a class interval. Let's go back to the example of the shoe size of people that are within a lecture room. Let's say you get into what? Into a classroom. What a class interval is you say everyone that has got a shoe size starting from 6 to 8, can you come and stand in that corner? So the moment you say shoe size from 6 to 8, what you have done there is you have defined a class, right? So now you are saying there are classes 6 to 8, right? And then maybe you say 8 to 10, or maybe just say, you can just say, maybe let's say 6 to 7, right? And then 8 to 10 to 9, then 9 to 10. So what you're doing is you are coming up with classes, right? You are coming up with classes. So 6 to 7 is what we call a class interval, right? So it is a class interval in which people are going to fall into. So what a class interval is, it is a term that is used to denote the numeric width of a class in a frequency distribution. So each class must have a width, and that width is what is called the class interval, the starting value of that class and the ending value of that class. So now that's why we are saying all the data, right, within a frequency distribution, they are arranged in form of classes, and each class must have 2 values. It must have what is called an upper class limit and a lower class limit. So in case of 6 to 7, so 6 is the lower limit of that class, and 7 is the upper limit of that class. In a class of 8 to 9, 8 is the lower value, because 8 and 9, 8 is the lower value. So that automatically becomes the lower limit of that class. So each and every class must have a lower limit and must have an upper limit, right? That consists of what is called a class interval, right? Then now, these class limits, right? These are the lowest and highest values that can be included in a class. For example, take the class of 30 to 40. So this is a class of 30 to 40. The lowest value in that class is 30. So that is your lower class limit. And then the highest value in that class is 40, right? So those 2 boundaries of the class interval is what we call the lower limit, or the lower class limit and upper class limit, right? So now let's explain what is called the class width, right? So now the class width, it refers to the difference between the upper and lower boundaries of any class or category, right? So mathematically, for you to determine what is called the class width, there are 2 ways of doing it. So the first way is you find the difference between the upper limits of neighboring classes. Like for example, coming back to what? To our example, all right? So let's say there is a what? There is this first class, right? Which is 6 to 7. And then there's this class, which is 8 to 9. So let me just change. So this part here, right? So these are what we call lower class limit, LCL. These are lower class limit, right? And then this one on the right here is what we call UCL, upper class limit. So for you to get a class width, it's either you choose whether to use lower class limits or upper class limits. If you choose to use upper class limits, then what you do is you need to find the difference between the upper limits of neighboring classes. So this class and this class, they are neighboring, because obviously when you start your class, you start the class with the lowest values going up, right? So maybe here there'll be 1, 2, 3 and 4, 5, right? And 6 and so forth, right? And then you get 6 to 7, 8 to 9. So you use these two neighboring classes to get a class width. So you say 9 minus 2. In this case, you get what? You get 2. To prove that this is 2, even if when you use these upper class limits, these lower class limits, you can say 8 minus 6, you still get 2. So it doesn't matter whether you use lower class limits or upper class limits of neighboring classes. You will still get the same answer, right? You will still get the same answer. So in this case, lower class limit, when we subtract these lower class limits, right? 8 minus 6, then you get 2. 9 minus 7, then you get 2. So that is how you calculate the what? The class width, right? So the class width, it is the difference between the upper limits of 2 consecutive neighboring classes, or it is the difference between the lower limits, right? So in this case now, right, this is how we're going to group, right? Let me just make some additions here so that people will not be confused, right? Okay, just give me a moment. All right, so that people, okay, just give me a moment. So now I'm the one who did this, right? But I'm going to show you later on when we start when we start the lectures, how you will come up with these classes. But in this case, we were told, right? We were already told that the lowest class limit must be 5. So the first class, right? The lower limit of that first class must be 5.00. All right, so like in this case, so 5.00, right? So in this case, this must not be right. 5.00, and then this one we can put it as 1 day, right? So in this case, it is the question, right, that gives us how we are supposed to make these class intervals. If it wasn't that they'd given us that there is a the lowest class limit as 5 and the class width as 2, then it will be up to you how to make these class intervals. But since your lecturer had already given you a hint of how you are supposed to make this class interval, so they said that the lowest lower class limit, which means that the first class, your first class, that lower limit, it must be 5.00, right? This is exactly what we did, right? This is exactly what what we did. Then how now do you group? How do you group these workers into the various class intervals? That is the question, right? Because they want you to group the data into a frequency distribution, right? So you have already made your class intervals, right? So the first interval is what? 5 to 7.01. To prove to you that the class width is 2, what you do here is, if you take these ones, right? If you take these ones, 7 minus 5, you get what? You get 2.00, right? If you say 9.01 minus 7.01, right? You still get 2.00. So how you come up with these classes is you say 5, right? 5.00, that is your lowest class limit, right? Your lower class limit. But you know that the next class, it must start because the class width is 2. So what you already do is you just say 5.00, right? Minus 7.00, right? And then you get your what? And then you get your 2, right? So how do you come up with what? How do you come up with this frequency, right? This column of frequency. How do you come up with the values like 2, 3, and 4? So what you do is you say our first range is from 5 to 7, right? 7.01. So you say how many people in this list, right? How many people in this list do have an hourly wage rate that is within that within that range? So in this case, we say 5.35 and 6.25, right? So you see that these two, they are less than what? They are less than 7.01, right? So 1 and 2, these are the ones, right? These two. So there are 2 people that fall within this what? Within this class interval, right? And then how many people fall within 7.0 to 9.01, right? You come and you say, you check from the what? From the list that you have been given, right? You say 1, 2, 3. This one is above what? This one is above 9, right? So you have 3 people. You have 3 people that are within that class interval, right? Then between 9 to 11, right? You just do the same thing again. 9 to 11, you say 1, 9 to 11. So it's starting here, right? So it's 1, 2, 3, 4. Yeah, there are 4, right? Okay, so someone is saying the class are 5.00 less than 6.99. Okay, the first thing that we need to know is the class must not overlap, right? So let's see if these classes are overlapping. Maybe I might have made a mistake here. Let me just see. Because the classes must not overlap. That's the first thing, right? So 5.00 less than 7.01, then 7.00. Yes. All right. Thank you so much. I think this is something that I overlooked, right? So the classes must not. You see that when we start these things, the classes must not overlap, right? The classes must not overlap. That's one condition, right? That you need to pay attention to, right? The classes must not overlap. So this becomes 14.99. All right. So when I was changing, I think just a couple of minutes back, I didn't verify whether the class is overlapping. All right. But thank you so much. So the classes must not overlap. When you're saying overlapping, the number that you write here must not be the number that starts here, right? So like here we're ending at 7.01, right? Of which here it was starting at 7.00. So the number that will be your upper class limit must not overlap with the lower class limit of the next class, right? So thank you very much for reminding me that that is a very, very, very important question. But don't worry, we are going to explain this much into much further when we start the lectures. But still, the concept is still the same, right? Let me just recap. We are saying the first class is starting from 5.00 to 6.99, right? So you're just coming back to your data. You're just checking which values lie within that class interval. So here we've got two people who've got an hourly wage which falls between 5 and 6.99, which is two people, right? And then again, the second class limit, it has 7.00 to what? To 8.99. So you come back to your data, right? You come back to your data and you check, right? 1, 2, 3, right? So there are 3 people who are falling within what? Within the class range of 7.00 to what? To 8.99. Then the next what? The next class interval, which is 9.00 to 10.99, right? You just check again from that data, right? 1, 2, 3, 4. There are 4 people, right? Then you come and then you put them in what? In that, you put this number in that class interval, right? Then the next class interval, which is 11.00 to 12.99, right? You come and you check again. 1, 2, 3, 4. Okay, we're starting from what? Let me see. From 11, right? So from 11 is what? It's 1, 2, 3, 4, 5. There are 5 of them, right? So these are what? 5 people out of 20, right? They fall into this class what? This class interval. So this is how you are grouping. This is what they call grouping of the data, right? This is what they call grouping of the data. You are grouping the data based on the class intervals, right? That you would have made. So you are now saying how many people fall into this class interval? How many people fall into this class interval? How many people fall into this class interval? This is this column, which is called the what? The frequency column, right? Then the question now, the other part of the question is saying include the cumulative frequencies, right? Include the cumulative frequencies. So when you have a column of cumulative frequencies, right? This one, which is highlighted, then you can calculate what is called a cumulative frequency. So when you are talking about cumulative frequency, it's more like you are just adding up the frequencies, right? You're just adding up the previous frequency on that frequency of that class, right? Like in this case, when you create this column, right, which is cumulative frequency, the first rule that you must know is the first cumulative frequency is equal to the frequency of that class. Like the first class in this case is 5.00 to 6.99, right? So the frequency, which is 2, automatically becomes the cumulative frequency. But for all the classes that come after the first frequency, right, the first class, so the cumulative frequency, you will say the cumulative frequency of the previous class, because remember, we want to find the cumulative frequency of this class. So you say the cumulative frequency of the previous class plus the frequency of that class. So this will be 2 plus 3. It will give you what? It will give you 5. Right? Then you say, if you want to calculate now the cumulative frequency of this class, you will say 5 plus 4. It will give you what? It will give you 9. Right? If you want to find the cumulative frequency of this class, you will say 9 plus 5, then it will give you what? 14. If you want to find the cumulative frequency of this one, then it will be 14 plus 4, then it will give you what? 18, right? The cumulative frequency of this class, it will be 18 plus these 2, it will give you what? 20. So the rule of thumb is you need to say the cumulative frequency of the previous class plus the frequency of that class. It should give you the cumulative frequency of that class that you want to calculate, right? Let me recap again so that people can get this. So if we want to find the cumulative frequency of this class, you say that the cumulative frequency of the previous class plus the frequency of this class that we want to find the cumulative frequency of. You say 2 plus 3, then you get 5. If you want to find the cumulative frequency for this one, we say that the cumulative frequency of the previous class plus the what? The frequency of this class, then it gives us 9, right? Then for this class again, we say cumulative frequency of this class plus the frequency of this class, which is 9 plus 5 gives you what? Gives you 14, right? For this class again, we say 14 plus 4, it gives you what? 18. For this last class, it's 18 plus 2 to give you what? To give you 20. So basically, this is how you what? You calculate the what? This is how you calculate the cumulative frequency of the what? Of the classes, right? So the other question now is determine the mean wage rate using the raw data. So this is the keyword, right? They said determine the mean for raw data. Just like I said, when we get into the lectures, right, you come to find out that there are different formulas, right? One formula is for calculating mean for raw data. The other formula is to calculate mean for grouped data. So in this case, they are asking you to calculate mean for raw data. So the formula for calculating mean for raw data is, you say mean is equal to sum of the observations divided by the number of what? Of observations. So when you're saying sum of observations are the data points, right, that we would have observed. Like in this case, we have observed that there are 20-hour wage rates, right? So when we say sum of all the observations, you are summing all the 20 hourly wage rates. So you are saying 5.35 plus this, plus this, plus this, plus this, up until you get to the last figure. So you are summing everything, right? So that's what it means by saying sum of what? Of the observations. Then you say sum of the observations over the number of observations, right? The number of observations is 20 because we took 20 people, right? We took 20 people to see their hourly wages, right? Their hourly wage rates, right? So it will be the sum of all those 20 hourly wage rates over the total number of the people that we observed. So in this case, when we add everything, you get 223.2 over 20. So the mean or the average, right? The average hourly wage rate is what? Is 11.16. So what does this mean, right? Because we are saying mean is the measure of central tendency. So how is it describing the data? If we get a mean of 11.16, how does it describe data? So it is saying roughly these workers, they get roughly around 11.16. That's what it means, right? When you get a mean when you get an average, roughly you are saying that is what the people get. Though there are people that get less than that, though there are people that get more than that, but roughly, if we are summing everything, we're saying roughly people get around 11.16. So this value is now describing the hourly wage rate of the people, right? Instead of you talking about each and every person, that this one gets this, this one gets this, this one gets this, you just find one value that describes all of them at once. So mean is that value. So it is saying roughly these people, they get a mean value of what? Of 11.16 rand per hour. So basically that is how measures of central tendency, right, describe the what? Describes the data. Right. So basically, okay, let's go to the next question, right? Let's see the next question. Was the next question here is talking about draw what is called an Ogive curve corresponding to the data and use it to estimate the median. So an Ogive curve, basically, what you need to know is an Ogive curve is a graph where you plot what we call the upper class limit and the cumulative frequency. Remember, when you come right, when you come back to this table, right, all these values on the right side, right, all these values on the right side, right, this one 6.99, 8.99, 10.99, 12.99, 14.99, and 16.9. These are upper class limits, right? So what you can do here is you just write the upper class limits, right? The upper class limits, and then you plot the upper class limits against cumulative frequency. So this is the cumulative frequency, this one. So you are plotting the upper class limits, these ones, against the cumulative frequency. When you plot those two, right, the graph that you get is what is called the Ogive curve, right? That is what is called the Ogive curve. So basically, when we plot this, we're going to show you later on in Excel how you plot this, right? So I actually plotted this in Excel, right? When you plot this in Excel, right, you get this curve. This curve here is what we call the Ogive curve, right? The Ogive curve. So now when you get the Ogive curve, you can actually estimate what is called the median from it, because where median is another value of what we call measure of central tendency. So we've got three of them. We've got a mean, we've got a median, we've got a mode. A median, it is a value that separates the data into two equal halves, right? The value that separates the data or divides the data into two equal halves, that is what is called the median. And then the mode, it is the value that occurs the most, right? When you're given a data set, the number that is repeated the most number of times is what is called the mode. So in this case now, when you draw an Ogive curve, it is very easy for you to calculate what is called the median. So when you have drawn an Ogive curve, right, for you to determine what is called the median, you come on your what, because when you have plotted cumulative frequency and upper class limit, so your upper class limit will come on the x-axis, and then your cumulative frequency comes on the y-axis, right? So the values on your y-axis, you find half of the maximum value. So in this case, the maximum value is 20. So you say 20 divided by 2, which gives you 10. So 10 is the number in the middle. So what you do is you draw a line from 10, right, going towards the curve itself, right? So you draw a line on the half of the values on the y-axis. So you draw a line from 10 going into the graph, right, up until it intersects, right, this curve, because this is the curve, the Ogive curve. So where this line meets the curve, you then draw another vertical line up until it crosses the x-axis. So the value that you get here, that is your median. This is how you get your median when you have an Ogive curve, right? So the first thing that you need to do, you need to find half of the what? The maximum value on the y-axis. And then you draw a horizontal line from that value up until where it crosses the curve. When it crosses the curve, you draw another vertical line going down. That vertical line, where the vertical line crosses the horizontal line, the value at that point, that is the median. So in this case, it is 11 point, around 11.4, because remember, 12 is somewhere here. 12 is somewhere here, right? So obviously, this is slightly below 11.5. So you can say, so someone might say it's 11.3, someone might say 11.45, someone might say 11.5. It's still okay. There won't be one value, but at least you can't say this is 13, right? At least if it is within that range, 11.3 to 11.55, that is okay, right? Your lecturer will mark it through. Then when you want to calculate the mean, okay, let's see the next one, the next question. So the next question now is saying another worker is included in this sample. What must be his hourly wage to make the mean exactly 12 rand? So what is happening now is there's another worker that has been included in this subset of people, right? Which is around 21, which is now 21. Because initially we took 20 people, right? 20 people, then we found the mean value, which was 11.16. But now the question is saying they've added another person on top, another person which makes the data set to have 21 people. So they are saying when we have added another person, they managed to get the mean, and then the mean was what? Was 12 rand, right? So they are saying, what is the value of the amount of the hourly wage that this person that was added, right? What is that value, so that we can get a mean value of 12, right? So basically, how you tackle this question is, you say, remember, you start by writing the what? You start by writing the formula where you say mean is equals to sum of observations over number of the observations, right? So we know that we already had 20 people, right? And their wages, we have them. So if we add everyone from the first person to the 21st person, you come to realize that the first 20 people, we already have their hourly wages. So that is this sum. But now, when we add the 21st person, we don't know yet their value, right? We don't know yet their value. So that's why we are saying, let X be the hourly wage of the 21st person. So we are saying, after adding all the wages of 20 people, when we add the 21st person, right, it will become 223.2 plus X. Then we divide that by the total number of workers, which is now 21, because we've added another person on top. So when we say 223.2 plus X, which is yet still unknown, over 21, then it must give us a mean of 12. So when we simplify this equation, because this becomes an equation, because X is unknown, right? So we say we cross multiply, because this is now basic arithmetic, right? We say 12 by 21, right? Then you get 252. And then when you make X the subject of the formula, then you get X as 28.8. So basically this is how one would have attempted this one, this this assignment, right? If I was a student, this is how I was going to work. This is how I was going to attempt this assignment. So basically, guys, this is just an overview of the business statistics lecture, right? So from next week, to those who are going to join us, right, we will now get deeper into the fundamentals, right? The fundamentals of statistics itself, right? Where we need to define certain terms, and now going into much deeper details of what we were talking about today, right? So I'm not so sure if there are any questions regarding what we have covered so far up until to this point, right? Just feel free to ask if you have any questions. Then if you don't have any questions, then I think James, you managed to say the information that maybe some of you guys would really want to hear, like the issue of the payment and so forth. So I think some of the issues you can even just ask James if you didn't really understand, maybe, you know, the amounts and so forth. You can just get a hold of James, I think, in the group where you are. Then James will attend to those issues. So guys, thank you so much for your time. So for those that are going to join us for business statistics, it will be Monday, same time, right? So I will meet you guys next week, same time, if there is no one with any question. All right.
Thank you. Are you done?
Yeah.
Okay. Thank you guys for coming in. I will meet you next week.
Okay.